Hello viewers, welcome back. Today we are going to understand subnetting in Azure VNet. As a part of the DevOps role, if you get a task to create two equal subnets in a VNet from the IP address space 192.168.0.0/16 or three unequal subnets out of the same IP address space. So, you identified the key factor here. We have address space, that is 192.168.0.0/16. Let's take this IP address for our task to do. And first, we need to split this IP address in two equal halves or two subnets, right? Okay, we can quickly figure out some parts of the two new subnets, but what about the remaining parts? Just take a second. Can you figure it out? Can you feel these question marks? What is the relevance of the two question mark after the slash? What it states? Let's check on Azure portal as well. Let's create a VNet in Azure dashboard. Here you need to provide new resource group name. Let me give it a name. I am Cloud1. Okay, let's provide the VNet name, VNet1. Next, let's directly focus on the IP address where we need to create the subnets. Here we see the address space 10.0.0.0 and there are many subnet masks. We already have predefined subnet created here, which is called as default with a CIDR/24. But question still remains the same, right? Even if I replace the address space 10.0.0.0 to our required IP address, that is 192.168.0.0, what should be the range of the two new subnets that we wish to create? Let's deep dive and understand when we say 192.168.0.0/16 what it means. It is a class C type of IP address for the private addresses. This IP address class range is defined by the global entity called as IANA, which is Internet Assigned Number Authority. That means any private address space, though it be your private router at home, through which right now you are connected, your mobile or your computer, or a VNet in Azure to which we connect VMs and other services, can have these class A, class B or class C IP address spaces. From the selected address space, devices are getting one of the IP addresses. Go ahead right now and open your command prompt and type ipconfig, ipconfig if you are on Windows, or ifconfig, ifconfig as a command if you are on Mac, and check your current private IP address. It should be from this address spaces only. So now you know that the task is to create a private address space with a class C address, which is 192.168.0.0/16. Let's understand what are these numbers separated by dot. These are called octets. The smallest number of this octet can be 0, whereas the largest number can be 255. But isn't that odd to call a 3 number as octet, which refers as 8? This is because an octet refers to 8 digits only, but in binary instead of decimal. Decimal is the human readable number system. Binary is a computer readable number system. In binary number system, one byte consists of 8 bits and each bit is representing either 0 or 1. This is how computer reads the IP address in binary. Let's clear our concept with 1 byte or 1 octet and understand why the minimum value is 0 and why the maximum value is 255 for each octet. In binary arithmetic, each bit within a group represents a power of 2. The first bit from the right in the group represents 2 raised to the power 0. The second bit represent 2 raised to the power 1. The third bit represent 2 raised to the power of 2, and so on till the last bit, that is 8th bit, which represent 2 raised to the power 7. It is easy to understand binary because each successive bit in a group is exactly twice the value of its previous bit. And if we calculate the total, the maximum number in the group of 8 bit, that is a byte or an octet, can be 255 if we put all ones in each bit, and the lowest number 0 if we put all zeros in each bit. So we need to add the power of 2's in the bit where we have 1 and ignore the bit where we have 0. Then we get the result as a octet value in our decimal number system, which is a human readable number system. Let's see some examples for this. Here we have ones and zeros in each bit of the octet. Let's calculate in decimal number system. In the 8th bit we have 0, skip it. In the 7th bit we have 1. Okay, so 7th bit is 2 raised to the power 6, which is 64, plus 6th bit we have 1, so we need to consider that too. 6th bit is 2 raised to the power 5, which is 32, plus 5th bit, which is 0, skip it. 4th bit is 1, so add 8. 3rd bit is again 1, add 4. 2nd bit is again 1, so add 2. First bit is 0, so skip it. So the total is 110 in the decimal number system. So the byte or octet represents 110, that is 110. Let's take one more example. This time you do it. Pause the video here, calculate and type the result in the comment, and then resume the video and validate your result. So what is your answer? Let's check. It's 128 plus 32 plus 8 plus 2, which is 170 in decimal number system. I'm confident you got one right. Likewise, if you want to represent minimum number, that is 0 in decimal, you can see it in example 3, all zeros, and for maximum number in decimal you need to keep 1 in each bit, which is example 4. It is 255. Now you clearly know how to convert a binary number into a decimal number. But what if you got a decimal and you want to convert it to a binary octet? Let's have a decimal number 177. You need to keep those bit 1 in the octet so that its 2's to the power of bits value sum is equals to 177. There are many ways you can do this, but let's take one of the simplest way. Our decimal number is 177. So is 177 greater than or equals to 2 raised to the power 7, which is 128? If the answer is yes, then the bit value becomes 1. And if it is less, then the bit value becomes 0. If we have the bit value 1, then next we need to subtract the last bit's value from 177. That is 177 minus 128, which is equals to 49. Now we have to compare the next bit with 49. So is 49 greater than or equals to 64, which is 2 raised to power 6? Answer is no. So the bit value becomes 0 and we need to further compare the value 49 to the next bit. Is 49 greater than equals to 32? Answer is yes. So the bit value becomes 1. Once the bit value becomes 1, we need to subtract the value from the current value. That is 49 minus 32, which is 17. For next bit, is 17 greater than equals to 16? Yes. Then the bit value becomes 1. And our remaining value is 17 minus 16, which is equals to 1. So is 1 greater than equals to 8? No. Bit value becomes 0. Is 1 greater than equals to 4? No. Bit value becomes 0. 1 greater than equals to 2? No. Bit value becomes 0. 1 greater than equals to 1? Yes. Bit value becomes 1. So this is binary representation of 177 in decimal. That is 10110001. Let's take another example here. What is binary representation of 205? This time you do it yourself. Pause the video here. Calculate the binary value as shown in the example 1. Write your result in the comment and then resume this video to check your answers. So, you got it? The answer is 11001101. I believe you got the answer right. If not, then just go through this calculation and validate your answers. So, now you know what is an octet, what is the maximum and the minimum value, and why 255 is the maximum value. Also, now you can convert binary to decimal and decimal to binary. Great. So, what is 192.168.0.0 would represent in the 32-bit number? Without any hesitation, now we can translate this with a standard formula that we just have. Now we have clear picture on the IP address. What is this /16? What it represents? Can we keep any number here? Answer is no. It is called as subnet mask /16 or CIDR. That is classless interdomain routing. The /16 tells you the first 16-bit out of these 32-bit are the network address space, and remaining 16 bits are the host address spaces. Wait, what is network address space? These are the fixed bits allocated to the network routing. These are fixed, hence in any case, as many subnets you create out of this address space, these bits will be constant. On the other hand, host address space is the space which is used to allocate one of the IP address to the connected machines. Okay, so network address space and host address space. How can I create subnet out of it? Subnet address space. This will help us to create multiple subnets out of a address space. But what is this subnet address space? So, we already know we cannot change the network address space, right? And we have host address spaces in our hand. So out of the host address spaces, we can allocate first, second, third bit as depend on how many subnets we want to create and set those bits as our subnet address bits. In our case, we want to divide the address space in two, right? That is 2 subnets, and one bit can handle 2 values in binary number system, that is 0 and 1. So our first subnet will have subnet bit set to 0 and the second subnet will have the subnet bit set to 1. In this case, we just need 1 bit as our subnet address. Also, because you have assigned 1 bit to the subnet address space, it becomes a fixed bit like a network address space. Hence, now my CIDR or subnet mask becomes 17. So, in my 2 new subnets that I'll create, I'll have 17 fixed bits and remaining 15 bits will be used as the host address space. My subnet 1 starting IP address will have all the host address bit set to 0. This value in decimal number system is 192.168.0.0. This is my starting IP address of subnet 1. And the last IP address of the subnet 1 will have all the host bits set to 1. This value in decimal is 192.168.127.255. Now we have complete clarity on our subnet 1. Any device that we attach to subnet 1 will always have IP address between this starting and the ending IP address range. For subnet 2, you see the subnet address space bit is set to 1, which was 0 in subnet 1's case, and the starting address will have all the host bits set to 0. This binary value represents 192.168.128.0, and it makes sense, right? Check the last IP of subnet 1 and compare the third and the fourth octet. In third octet, we have 127 as the last value in the octet. And in second subnet, it takes the next value, that is 128. And in the fourth octet, as 255 was the maximum value possible, the next value starts from 0 again. And the end of the second subnet has the subnet address bit set to 1 and all host address bits set to 1. This is 192.168.255.255, which is the last IP of the subnet 2. So we have subnet 1 and subnet 2 IP address range. Instead of specifying the range, same can be represented by specifying the subnet mask or CIDR with the IP address. So, are you now clear with the value here that we have calculated for subnet 1 and subnet 2? Yes, we have our two subnets here, and we now know how we calculated these subnets. The total IP addresses possible in 192.168.0.0/16 is 65536. That is, these many IP addresses are there in this range. This is nothing but the maximum combination of host IP address space bits. So we can allocate IP address for 65535 devices, may it be a VM in Azure or any dedicated Azure service. And when we divide this in two, each subnet can now provide IP addresses to maximum 32768 devices. Let's rubber stamp our theory with practical and continue where we left off while we were creating subnet in the VNet in Azure. By default, we have 10.0.0.0, which is a class A address space. We need to replace that with 192.168.0.0. Good. Also, by default, it is populating /24 address space for our subnet. We don't want it. Let's delete it and add a new subnet here. We have the starting address set to 192.168.0.0 as we had for our first subnet. We need the /17 CIDR size for 32768 IP addresses. Do you see the subnet address range? 192.168.0.0 to 192.168.127.255. This same as we have calculated earlier. Okay, let's add it. Add another subnet. This time the starting address space is 192.168.128.0, same as we have seen in the theory. Change the CIDR size to /17. And we have second subnet address range from 192.168.128.0 to 192.168.255.255. Yes, we have already calculated this. And add this subnet to the VNet. Review and create. Create. Go to resource. We have our VNet 1. Our address space is rightly set. And if you go to the settings, you have subnet section where you can see the list of all your subnets. Here we have both the subnets with the subnet mask /17. I hope now you understand how to divide an address space into two equal halves. But life is not that simple for DevOps engineers, right? Let's consider your next assignment is to create 3 subnets, and this time it should be an uneven subnet. You need to have one big subnet with 32768 IP addresses, and remaining 2 subnets should be smaller, that is 16384 IP addresses. Let's see this quickly without taking much time. You know the basics now. Network address space, host address space, and subnet address space. But our basic theory says 1 bit is not enough for representing 3 subnets, as 1 bit has only 2 states, that is 0 and 1. So 1 bit is not enough for 3 subnets. But 2 bit can represent 3 or even 4 subnets, as 2 raised to the power 2 equals to 4. But we need 3 only. So we have 2 bits for our subnet address space. The 4 possible combinations are 00, 01, 10 and 11. Good. But we need 3 only, and that too 1 big subnet and 2 small subnets. So for first big subnet, we set the subnet address bit to 0, only 1 bit. And for second and the third subnet, we need to use both the bits. As first bit's 0 already reserved for subnet 1, for subnet 2 and 3, we set subnet address bit 1. For second bit, we set 0 and 1 for second and the third subnet. Now you can see our 3 subnets in binary. Here, for our first subnet, we utilize only 1 bit, whereas second and the third subnet we are utilizing 2 bits. Hence, the CIDR for the first subnet is /17, as it is using 16 network bits plus 1 subnet bit. And second and the third subnet will have /18 as CIDR or subnet mask, that is 16 network bits plus 2 subnet bits. If we convert these binary to decimal, then we get our 3 subnets start IP addresses, where we keep the host address bits to 0, subnet 1 192.168.0.0/17, subnet 2 is 192.168.128.0/18, and subnet 3 is 192.168.192.0/18. And you can calculate the end IPs of all 3 subnets by keeping all the host bits to 1. So my subnet 1 ends at 192.168.127.255, and my subnet 2 starts with 192.168.128.0. Makes sense, right? After 127, in the third octet, we have 128. Same you see in the second subnet ends. 192.168.191.255, and the third subnet starts at 192.168.192.0, and our third subnet ends at 192.168.255.255. Great. Let's see this in only decimal values and move to CIDR annotations. Now you can give the result here to the question marks. Yeah, we have smartly divided the address space 192.168.0.0 in 3 unequal subnets, in which the first subnet can provide IP addresses to 32768 devices, and second and the third subnet can provide IPs to 16384 devices. Let's quickly see this in action in Azure portal. Change the address space to 192.168.0.0. Delete the default subnet and add a new subnet. See the starting IP for our first subnet, that is /17. Add subnet. We have 32768 addresses here. Add another subnet. starting address is already 192.168.128.0. Select size /18 for our second subnet. Click add. Default 2 is our second subnet. Add another subnet. This time the starting address is 192.168.192.0, which has been calculated already in the theory. Select size /18. Click add. We have all the 3 subnets that we need. First with /17 CIDR and remaining 2 with /18 CIDR. Click review and create. Create. Go to resource. If you click address spaces, you can see our address space 192.168.0.0 and the address count is 65536. Click on subnets. Here we have all the 3 subnets that we have created. With this knowledge of creation of even and odd subnets, you can now create any number of subnets from any address space. Just stick to the basic theory that we have gone through. How did you like this video? Please ask in the comment any question that you have on this. Thank you so much for watching this video. If you like it, give it a thumbs up and consider subscribing for more contents. Stay connected by pressing the bell icon to get notified for the upcoming videos. Thank you.